All right, just talking about Ruby under a microscope, chapters 7 and 8. Chapter 7 is all about the hash table. Chapter 8 is all about, it's called How Ruby Borrowed a Decades-Old Idea from Lisp, and it's all about procs, lambdas, and blocks. So all kinds of fun stuff there. And we were just talking about how these chapters are short, but quite dense.
Yeah, and while I was reading about it, I kept thinking, how is this going to provide me any value on day to day? And I don't know that it will right now. I think it'll be later on where I'm debugging something and I think back to this book and think, oh yeah, that's how that works. That's how hash tables work, or that's how blocks work. And it might give me some insight on some performance improvements, or at least a reference to go look at that chapter in the book. I'm struggling to see with how this will help me on a daily basis.
Yeah, yeah, I hear you. Let's see, do we have a section? No, we need to make a section. Okay. Yeah, I thought it was really interesting, the whole idea of these hash, I think it's the hash table one, where it's like got all the bins, right? And it puts different items in the bins and tries to sort of evenly distribute them. And then once they get so full, it makes new bins and has to rehash everything. Which, you know, is far beyond my understanding in terms of like what that means in terms of optimization and under the hood, what the computer's doing with that information and why it's faster, better, or whatever. But there's an interesting part where they said something about hash collisions. So if two or more elements are saved into the same bin, that would be considered a hash collision. But I was like, I thought the whole point of the bins is that they contained multiple items, like up to 5 or 6 items in a bin. And it says that means Ruby is no longer able to uniquely identify and retrieve a key based solely on the hash function. I thought that was interesting too, because I feel like unless it's the exact same key, it seems like even if it's in the same hash bucket of like 5 or 6 items, it should still be quite unique. So my only comment there was like, why not? Why can't it? Why can't it find it and consider it unique anymore? And I'm wondering if they maybe just meant the bin number, but I don't know. I don't know how that works.
Yeah, that's the note I put. So hash collisions happen when 2 entries are saved to the same bin. And once, and the way I read it was they had a hard-coded limit to density. Once it exceeds 5, then they expand the number of bins that they have and they rehash. Right. And I thought it was interesting that for hashes that contains 6 or fewer elements, just an array, right? They're not actually doing a hash table. And it's, again, calling back to my .NET history here, that's how they implemented what was called a hybrid dictionary. And you literally just called it a hybrid dictionary. And for the first, I believe it was 50 elements, you actually got an array back. But once you got past 50, then it became more of a linked list, or I'm sorry, a hash table. So I wonder where these arbitrary numbers came from. Like, why is an array of 6 okay, but an array of 7 now needs to become the hash table in the bin array?
Yeah, I mean, I'm wondering if that's related to the prime number kind of thing they had going on, if they just chose, you know, 6 to 7 instead of like 10 to 11. But
I had assumed it was related to the density with, you know, if each linked list is like 5 or 6 long, then if we just have 5 or 6 to begin with, it might as well be an array before we start making the individual linked lists that are the same length.
Yeah.
Yeah, that whole chapter I thought was interesting. Just kind of like digging down into like structures, data structures. Like a realm I don't think about a lot, but it was kind of like, it was fascinating to see how it's all put together.
So Steve, before you joined, I was pontificating where I would actually use any of what I've learned in this book in my day-to-day, and you're much more elbow deep in this stuff than I am. So are you going to be able to apply anything you learned from this book on day-to-day, or is this going to be more later on?
Overall, no. that's the straight honest answer is overall no, but there are a few things that have stuck out so far in the book, specifically seeing how modules are actually tied to classes by just, making it a superclass, like inserting it as a superclass. That I think will help me understand better when I'm looking at, a class full of modules and the module has a bunch of modules, and like following that line and understanding well, which method is it actually going to read. I think that'll help me think about that better. And I think there's one other aspect. Oh yeah, the message calling. I had never, like in Ruby, I never thought of things as messages, like sending messages to an object, whereas like this helped me maybe start thinking with that mindset a little bit more. And it helped me finally maybe ingrain the idea between, in Ruby, there's send and call. And I used to always be like, well, which one do I have to use in which situation? And now it totally makes sense. Oh, it's send when you're sending a message to an object. It's call when you're calling a function from within an object or module. So those are the two things that I think will stick with me so far that I might think about from time to time.
Nice, yeah.
The hash stuff, not so much.
Yeah, I was wondering, like, are there ever cases where we would manually create a hash table in Ruby for a similar type, storage of many hundreds or thousands or millions of objects? Like, is that something like we would ever need to implement, or would we just say, oh, here's a hash, Ruby under the hood is going to make us a hash table?
Yeah, we would just use Ruby's hash.
Okay. Yeah.
I can't imagine a reason we wouldn't use it. If we got to the scale where it was like the Ruby hash isn't performant enough, then we're looking for, that's when you start saying, well, do we need to look at other languages for this specific problem?
Interesting. Huh. Yeah, I guess that makes sense. Since hash just goes straight to the hash table, why would you use anything else? It's a very simple structure. Yeah.
Yeah, I was looking through my notes again and back to the previous point, Steve, that you said about prime, or was it Dallas, about prime numbers? The note in there that Ruby does use an algorithm based on prime numbers to determine the number of buckets required in each hash table. So it might be the same thing from converting to an array to the hash table.
Yeah, that algorithm really struck me too. I was like, how's this working? Like, did they pre-find these numbers, and they're just like the plus and minus or the plussing that he shows there? Where is that on?
Well, they've got perfect squares, and then plus whatever it takes to get to the nearest prime.
The nearest prime. So did they pre-figure that out and they just put those in? Like, is that literally, like, is he just showing the code that's literally there, or is he kind of showing what that code does? Like, I'm just really curious, like, who took the time to figure out these nearest primes and put these in here, and how far does it go since it does that snip there after 512? Like, how far does it keep going?
I found it interesting that they use primes. Like, it makes sense for
it really does make sense.
Equal distribution.
Yeah.
I don't know if I understood why they relate it to those, those multiples of 2.
2, yeah.
Or the powers of 2.
I guess it's just a way of sort of doubling the size every time.
Yeah, because when I see powers of 2 in code, I'm like, oh, does this have to do with memory or something deeper? But in this case, it's just, these are like number of buckets, which may or may not have something underlying doing with memory. But yeah, I wonder why they split it out like that.
Yeah.
We were talking about something similar in coffee chat today, this week. And I'm wondering if this is like an artifact of the time when Ruby was written, because it was written in the early 90s, right? when memory was a little more expensive and you had to be more thoughtful about what you're using in memory. Whereas now it's like, just throw some more memory at it. It's cheap, who cares? Because we have the primary key overflow issues in our database where the events table and the CI builds table were written with the Ruby default, the Rails defaults of integer. And we have used up half of the available IDs to this point in time. And now we need to go through a painfully massive migration. Yeah. Get them there. So I wonder if this is just an artifact of those days where memory was a little more front of mind when you were architecting these things and you had to be a little more stingy with how you use them. And now it just doesn't make sense anymore because, again, memory's cheap.
Maybe. Like the only thing I can think of that, well, the one thing that I thought was interesting is that it's double every time. So if you've got a 256 element bucket, when you get to 257 or whatever the prime is, it essentially doubles. It's not just like adding, oh, here's 10 more in case you need it. It's no, here's another 256 more. So is it common that for given sizes, once you start to grow, it's like you can expect you're going to be growing by a lot and not by a little every time? Like, is it an exponential kind of growth pattern?
It's probably just a shortcut. I don't know.
Yeah.
Say like, hey, if you've got this far, then we'll just give you double the space. Like, I don't know. Because you notice like in the graphs, like those moments take a lot more, right? Each time you insert that number element that makes you rehash, you're going to take, looks like at least twice to 3 times as much time to do that. So yeah, I don't know.
That's true. Maybe that's part of it, is that like once you get to the higher numbers, you want to rehash less often. Less often,
yeah, because it's pretty expensive, I can imagine. Which kind of gets me back to this idea of, you know, if we use like a million item hash, like at what point does that just become, like you say, I guess, unperformant? Like how high does this go before it's like, okay, the next time you put in an element, it's going to take 5 seconds to rehash everything and then insert, and then we'll be good for, you know, like, where's that point?
I wonder what some of the biggest hashes we deal with in our code base are. I don't know.
That's a good question. They're probably not that big. I don't know. I'm trying to think of what would be a big hash. Like anytime you pull in, you know, a whole row from the database, I assume, is that a hash? I don't know actually. How does it do attributes under the hood? Are those just all individual variables?
Yeah, it's an object. So each instance, each record is like an object pretty much, and the attributes are part of the
variables. Yeah.
Instance variable table.
Yeah.
The record set is returned as an array, right? It's not.
Yeah.
Well, kind of. When you get a record set, it's an active record relation object.
Until you tell it to do something else.
Yeah, and then as soon as you loop over it, it's an array.
Yeah. I'm sure there's a lot of hashes under the hood, though. Like Rails itself probably uses all kinds of.
Yeah, that's what it sounds like, is it's using it all over the place.
Yeah. Yeah, that'd be interesting to try to do some sort of analysis at some point to figure out where our largest hash object is and how big it is, and whether or not we expect it to keep growing at some point or not. So I feel like there were a couple things that, like, for me, could be useful in my day-to-day. Like one is this idea that, you know, as a hash grows, it has to rehash every so often. And that takes extra time. So don't let your hashes get too big, which I don't know if I've ever had a problem with, but it's nice to keep in mind. And the second one is the idea of the blocks, where they kind of compared like doing a while block versus doing like the .each version, and how much, you know, faster the while version was, like 70% faster or whatever. I'm just kind of thinking like, yeah, just kind of thinking like, you know, like they said though, in Rails, there's probably so many like .each type blocks, and it won't matter by the time it gets to your little chunk of code. But just in general, I guess in Ruby, it's nice to kind of think about that idea. Like if there's some bottleneck somewhere that's using a lot of, .each type blocks or loops or whatever, or similar blocks, if you can convert them into non-closure style blocks, you could maybe save some milliseconds. I don't know.
I wonder if that would, this is absurd, but if we, as GitLab, we overloaded the .each mechanism to actually convert it to a while loop, and how much efficiency we would get.
Yeah, I don't know.
Oh, wow.
I wonder if I feel like I don't see much of any while loops. I wonder.
Yeah. No, the
.each
is super convenient.
Yeah.
And way more expressive, I feel like, in terms of like object-oriented style.
Yep.
Yeah.
Yeah, I thought the blocks were interesting in that. So I used to do a lot more JavaScript development, and the one thing in JavaScript that you do a lot is you pass functions as arguments of other functions, like what do they call it, higher order functions. And blocks kind of look like that, but not really. And so it's always annoyed me that like I can't just like say, def my method and then take my method and just pass that as an argument to another method or function somewhere else. And like what I kind of got out of this is like, maybe I can kind of do that. It just looks a bit different, and it's in the form of, blocks and lambdas, which is just less common of a pattern in Ruby.
Mm-hmm. Yes, I agree with the way you described it, Steve. I'm trying to think of the equivalent in other languages, but there are ways in .NET that you can pass methods as arguments.
Yeah, and you end up like, they end up being like a callback function pretty much.
Yep.
That's what they end up calling it.
Yep. So, Lambda, that seems like an odd call though, because I'm first time I encountered that in software was through AWS, right? Which is slightly different.
Yeah. Or it's big in like, isn't there like something with functional programming that has to do with like lambdas?
Oh, yeah. Is there a language or something?
Yeah.
I'm thinking of.
I don't remember.
Yeah. Yeah. AWS Lambda. Isn't that like kind of serverless or whatever style? You sort of write your service as a little function, and it can just run it ad hoc. Yeah. Okay. Yeah.
So it did help me better understand JavaScript closures. Because with JavaScript, I like they would always have the interview question like, "What is a closure?" And I would just always say it's a function in a function. But like the understanding of it's a function that carries the environment of the function that it's in, like that.
The scope, yeah.
Yeah, I liked the way they described that, where it's, you kind of have that picture of like there's a pointer to an environment that it will know about when it actually gets run.
Yeah.
So, yeah, it's called.
Yeah, I thought that whole section about how like the stack gets copied into the heap and then the pointers get all updated, and if there's more than one, it points to the same. I was like, wow, that's a lot. That is a lot going on.
That part got a little complicated.
It got me very nervous. I was like, what if something somehow points to the wrong spot? Like, I can't imagine being the people who were writing and testing that, to be like, okay, now are we sure it's pointing at the right section of variables? Like, all right. Yeah. Because it works just like you would expect it to, but you couldn't really define why you expect it to work that way, or what exactly under the hood you expect it to be doing. But yeah, that's not quite what I expected under the hood.
Yeah, the example they gave about calling the Lambda more than once in the same scope, that seems odd. But I mean, as long as we know about it, now we know, like maybe that's something you can apply later on. If you have unexpected behavior, like, oh, okay, it's because I'm calling Lambda in the same scope more than once. Especially with the local variables where they demonstrated, the increment of I on the two different Lambdas. I was not expecting that. But of course, as I was reading it, and they were saying, "What do you expect?" I'm like, "Oh, I'm probably wrong in what I expect here, and they're going to show me why I'm wrong." So
exactly.
yeah.
Yeah.
And I thought it was interesting when they said a proc is a Ruby object and contains the same information as other objects behind the scenes. So that's clearly how they can pass them around.
Yeah, it was cool when they compared it to like was it R string or whatever, and then R proc, whatever it is. I was kind of like, oh, okay, I sort of get it. It's like a built-in type or whatever. It just happens to wrap a block, which then points to, that sort of function definition in that environment that we were talking about. That makes the closure. And then everything else it needs is just copied down into the heap, so it's there and doesn't get discarded with the garbage collector. But yeah, it's really, I don't know, the whole idea of like making a copy and then updating the pointer of that to be to the copy. And then if we have more, then they all go to the same copy. It's just like, whew, that is a lot of checks.
Yeah, I'm glad we don't deal with pointers.
Yes. I think I struggled with that the most in college when we were first learning about it, right? Because it's such a weird concept when you've never been exposed to it before. And then I spent my first several years in C++, and that's all about pointers and allocating, deallocating memory, right? You can,
yeah.
It's all kind of fun chasing those down.
I took a C++ class in college, and it made me never want to be a developer. And then 8 years later, or not 8 years later, like however many years later, I was like, oh, there are other ways.
Yes.
There are other ways. Thank goodness there are other ways. Other people got just as fed up and they did something about it. They're like, I'm writing my own.
Yeah.
Oh, that's great. That's funny. I kind of took like graphic design courses, and part of them, like one of them was about, just basic web stuff where you like, back in the day, it was like, you make up some HTML tables and maybe a little CSS or whatever. And as soon as I saw JavaScript, I was like, this is interesting. Like I could write in this. So yeah, totally different ways of coming around to it.
Yeah. I don't have anything else in my notes. Thought it was interesting how they explained why the .each was different in the while loop, and the in-depth explanation they had about has to create the new stack form, has to set the EP for the new block, needs to create the new structure, needs to pass the block call into each, and whereas the while, it just needs a check. It needs to reset the program counter. That's it.
Yeah.
All right. What's the next chapter? Chapter 9, meta programming.
9. Yeah, is that one long enough? That's kind of short too, it looks like. Maybe not.
Are we caught up with the other folks?
I think they might still be.
Looks like they're one.
I think they did it.
ahead.
They did chapter 9 yesterday.
Yeah.
It does look like chapters 10 and 11 would do well to be combined because they're both, one's JRuby, Ruby on the JVM, and then the other is Rubinius, Ruby implemented with Ruby.
Cool. So we
it might
can do
be good to
9 and
combine
then do
those
10
two.
and 11 later.
I think I'm most excited for the garbage collection one at the end.
Yeah, me too. That'll be interesting.
Nice. All right. Well, until next time, we'll just do chapter 9 for next time, meta programming. That will be fun. Oh man, yeah, meta programming, good times.
All right, see you guys. Have a good evening.
Catch you later.